Good morning to all. Welcome to Sigma e-learning Smart Way to Excellence. The topic we'll discuss today is pair of linear equations in two variables. Before going to the explanation, we'll make a quick revision of polynomials which is discussed in previous classes. Who are not seen my classes of polynomials, please go through it. Just we'll make a quick revision of it. In polynomial class, we discussed the conditions to be satisfied to call it as a polynomial, the conditions to be satisfied to call it as a not polynomial. Also, we discussed the type of or name of polynomial, whether it is linear, quadratic, cubic, based on degree, and graphical representation of polynomial. Linear polynomial always giving the straight line, quadratic polynomial always giving the u-shape or parabola. It can be reversed U or reversed parabola also. So every polynomial has certain number of roots. The number of roots means the number of points that particular polynomial cutting the x-axis. For example, the linear polynomial group, it has only one root, that is 3 by 2. So at 3 by 2 0 point, this linear polynomial cutting the x-axis. This is the quadratic equation. It has two roots. The root 1, minus 1 is the one root, 4 is the one root. So at minus 1 and 4, this quadratic polynomial cutting the x-axis. So it has two roots. Cubic polynomial has three roots. Because of this reason, it cut the x-axis at here, at here, at here. Means it has three roots, minus 2, 0, 2, or three roots of this cubic polynomial. Linear polynomial has maximum one root, quadratic have maximum two root, cubic have maximum three roots. Maximum two roots means it can be have one root, it can be have two root. For cubic polynomial, it can be have one root, it can be have two roots, it can be have three roots. If any function doesn't have any root, it means that doesn't cutting the x-axis. For example, this is the quadratic equation, polynomial graphical representation. It doesn't have any root means it doesn't cutting the x-axis. So this quadratic equation not cutting the x-axis. The relation between the coefficients of polynomial and the roots alpha and beta. So sum of roots is called minus b by a, product of the roots is c by a. The same thing also we had discussed in previous class for the cubic polynomial also. Based on the sum and product of roots of quadratic polynomial, we can express quadratic equation in this form. The pair of linear equations in two variables. Just after the pair of linear equations in two variables means the polynomial is the linear or the equation is the linear and it has the two variables. For example, observe this linear equation. It has two variables, x and y are the two variables, and it has degree 1. So it is the linear polynomial or linear equation. The difference between the polynomial or equation is simply when particular polynomial equal to something, it can be 0, it can be 1 or 2, 3 or any number. When equate particular polynomial is called as a equation. When we doesn't equate to any number, then we call it as a polynomial. For example, 3x plus 4y minus 20 equal to 0 is the linear equation in two variables. 3x plus 4y minus 20, just 3x plus 4y minus 20 is called 3x plus 4y minus 20 is called just a polynomial. When we equate it to 0, then it will become the linear equation. So that's the difference between the polynomial and equation. In graphical method of pair of linear equations, we can conclude the nature of solution. Pair of linear equations has many solution or unique solution, or it doesn't have any solution based on the behavior of the graph. For example, this line is the one linear polynomial in two variables. This line is the one linear polynomial in two variables. These two polynomials parallel to each other. They doesn't cut anywhere. These two linear polynomials parallel to each other. They doesn't cut each other at anywhere. So it doesn't have any solution. So these two linear pair of linear equations are inconsistent. So these two linear equations are inconsistent according to graphical expression. For example, come to the intersecting lines. For example, this is one linear polynomial, this is the another linear polynomial. These two linear polynomials are intersecting at this point x and y. So when two linear equations intersect with each other at particular point, it has unique solution or only one solution at x and y. Then come to the coincidental lines. For example, this is the one polynomial or linear polynomial graph, and next linear polynomial graph also lying on the same, means already ఉన్న లీనియర్ పాలినామియల్ పైన ఇంకో లీనియర్ పాలినామియల్ దానిపైన రెండు లైన్లు ఒకదానిపైన ఒకటి అమరి ఉండడం. సో దట్ ఈస్ కాల్డ్ కోఇన్సిడెన్స్ ఆఫ్ పాలినామియల్స్. అట్ దిస్ కండిషన్ it has infinitely many solutions, not the single particular solution. The behavior of graph by comparing the coefficients of linear equations. The behavior of linear equation can be concluded from the graphical representation as well as comparing the coefficients. For example, observe this. These are the two general expressions of two different linear equations. So compare this with this linear equation. For example, these two are two different linear equations. This is a1, this is a2, this is b1, this is b2, this is c1, this is c2. Just I am comparing this pair of linear equations with this general expression. So a1, a2, b1, b2, c1, c2. By comparing the coefficient ratios, we can conclude the behavior of the graph or the nature of the graph or the nature of the solutions. For example, in this polynomial, see here, a1 by a2. a1 is 2, a2 is 4. Here b1 is 3, b2 is 6, c1 is minus 9, c2 is the minus 18. By solving this became 1 by 2, it will become 1 by 2, this will become 1 by 2. Means a1 by a2 equal to b1 by b2 equal to c1 by c2. So this is the condition for the coincidental line. So when the lines are coincidental, it has infinitely many solutions. Means these two linear polynomials in the graphical representation looks like this. These are coincidental solution. Because of this reason, it has many solutions. Infinitely many solutions. For example, x plus 3y equal to 6, 2x minus 3y equal to 12. These are two different linear polynomial equations or linear equations. When we represent graphically, we'll get the one polynomial line, one linear polynomial, this, another polynomial line, this. These two polynomials are intersecting at particular point 6, 0. So the solution of these two linear polynomials is 6, 0. Charan went to shop to purchase some pants and shirt. The number of shirts is 2 less than twice the number of pants purchased. Also, the number of shirts is 4 less than 4 times the number of pants purchased. How many pants and shirts the Charan can brought? So this is the question. For example, let's imagine shirts equal to y, pants equal to x. From the given data, we can say that the number of shirts is 2 less than twice the number of pants. For example, we imagine the shirts as a y. So the number of shirts is 2 less than twice the number of the pants. Twice the number of pants means 2x. Why? Because x is the pants. So twice the number of pants. So 2x. 2 less than the shirt is 2 less than the pants. So I'll make it as minus 2. So this I converted this entire sentence into the mathematical form. Then come to the second sentence from the given data. Number of shirts is 4 less than 4 times the number of pants. So y equal to 4 times the number of pants. So 4x. 4 less than, so I make it as 1 minus 4. Y equal to 4x minus 4. I'm just converting the statement form into mathematical form. Now I got the two linear equations. These two linear equations are represented in the graphical form. For example, this is the one linear equation, this is the another linear equation. At 1,0 point, these two linear equations are coincident each other. At 1,0 means x coordinate is 1, y coordinate is 0. We have imagined that pants are x, y shirts are 0. So the Charan can purchase one pant, 0 shirts only. This is the possibility the Charan can purchase by satisfying the linear equation. By comparing the coefficients also we can do. By comparing about two linear equations, a1 by a2 is not equal to b1 by b2. For example, a1, this is a2, this is b1, this is b2, this is c1, this is c2. a1 by a2 is not equal to b1 by b2 because 2 by 4 is not equal to 1 by 1. So when a1 by a2 is not equal to b1 by b2, we can conclude that it has the unique solution, means it has only one solution, that is 1 0. This is the unique solution I got by comparing the coefficients. How to find the coincidental lines? Simply, when second polynomial equation or second linear equation formed by multiplying first linear equation with fixed number. For example, observe his 2x plus 3y equal to 9 is the one polynomial, 4x plus 6y equal to 18 is the another polynomial. First linear, by multiplying first linear equation with 2, I got 4x plus 6y equal to 18. 2 into 2, 4x, 2 into 3, 6y, 2 into 9, 18. Just by multiplying first linear equation with 2, I got the second linear equation. If any pair of linear equations formed in this way, then we can directly conclude they are coincidental lines. The solving of equations. Any two linear equations solved by this given manner, I will explain now. For example, x plus y equal to 5 is the one linear equation. 2x minus 3y equal to 4 is the another linear equation. The step 1 we have to do here is we have to equate any one of the variable. For example, we have 1x here, we have 2x here. To equate these two x's, we can multiply with 2 to the first linear equation. For example, 2 into x plus 5. Just I am multiplying with 2. 2 into x plus y equal to 2 into 5. Just I am multiplying x plus y with 2. So 2 into x 2x, 2 into y 2y, 2x plus 2y equal to 2 into 5 10. So after multiplication, first linear equation with 2, I got the 2x plus 2y equal to 10. I'll keep the second equation as it is, 2x minus 3y equal to 4. In step 2, I subtract equation 2 from equation 1. For example, this is the equation 2. I am subtracting from equation 1. So 2x minus 2x means this entire equation, subtracting this entire equation. So this equation minus this equation, we are doing the operation. So 2x minus 2x, we are cancelled. So minus 1, sorry, minus into minus, it will become plus. So I am keeping a plus in the yellow sketch. So 2y plus 3y became 5y, 10 minus 4. Why? Because minus into plus, it became minus. So I kept the minus here. 10 minus 4, 6. So 5y equal to 6 means y equal to 6 by 5. By subtracting the 6 by 5 in first equation means x plus y equal to 5, I got the value of x, means x equal to 5 minus 6 by equal to 19 by 5. So the answer is the value of x is 19 by 5, the value of y is 6 by 5. This is all about linear equations in two variables and their solutions. Thanks for watching. Please subscribe and share.